equal to 1 if p is congruent to 1 mod 4, and equal to minus 1 if p is congruent to 3 mod 4. To prove this, we can use the Euler's criterion. Using the Euler's criterion, Euler's criterion states that n bar p equal to minus 1 raised to minus 1 by 2. Here we choose n equal to minus 1. Then minus 1 bar p equal to is congruent to, this is not equal to, okay, you have to correct, this is congruent to, so it's a writing mistake, it's a mistake, so it's congruent to, now here it is correct. In minus 1 bar p is congruent to minus 1 raised to minus 1 to the power of p minus 1 by p minus 1 divided by 2 mod p. Next we want to establish the equality between the numbers, the Legendre number minus 1 bar p and minus 1 raised to p minus 1 divided by 2. This is the Legendre number, the Legendre symbol minus 1 bar p and the number minus 1 raised to p minus 1 divided by 2. So here now we have initially we have the equation as a congruence equation. Okay, this is the equation which connects the Legendre symbol value minus 1 bar p to the number minus 1 raised to p minus 1 divided by 2. But we know that minus 1 bar p equal to either plus 1 or minus 1, so excluding 0. So see here it cannot be equal to 0. Also we also know that minus 1 raised to p minus 1 by 2 equal to plus 1, either plus 1 or minus 1. So that depends upon the value of p. Okay, and thus we have both values equal to plus 1 or minus 1. Next we have to consider all possible combinations of these values plus 1 and minus 1. Therefore we can prepare a table. In this table, first column we consider in the first column the number the Legendre symbol value minus 1 bar p, and the second column we can write the possible values of minus 1 raised to p minus 1 by 2, and in the third column we will evaluate the value minus 1 bar p minus 1 raised to p minus 1 by 2. So you can pair the values of the first two numbers, and that's 1 1 1 1, and this in the second case we have, so in the first case if both are 1, then we get 0 here, 1 minus 1 equal to 0. So assuming that the first number equal to 1, the second number is minus 1, then we get 2, and if the first number is minus 1, the second number 1, then we get minus 2, and if both numbers are minus 1, that possibility is there as the fourth case, then then also we have 0. Thus finally we can see that all the possible values of the entire expression minus 1 bar p minus 1 raised to p minus 1 0 and plus 1 minus 2. Okay, and now it is also clear that but you know that this quantity, this difference quantity, the difference of the two numbers must be divisible by p. Also you should also note that in order to decide what the actual value for that expression, that will help to decide the actual value for the expression. Since this quantity is divisible by p, and that comes from this statement, you have to decide, and since p is a prime number, an odd prime number, so that quantity cannot be equal to either plus 1, it can neither be equal to plus 1 plus 2 or nor minus 2. It can either be plus 2 nor minus 2. So that only one possibility there remains, and that is 0. And thus we get that the difference equal to 0 always in all the cases, in all these four cases. Okay, always the value for that quantity will be equal to 0, and that means we have that means the number, the Legendre symbol value minus 1 bar p equal to minus 1 raised to p minus 1 by 2. So this is an error actually, and you have to avoid this number. So here we have on the left side only 1 minus 1 bar p. To complete the proof, we have to evaluate the value minus 1. Okay, now what now remains is that the second part of the result. Here you have to show that thus we have established that minus 1 bar p equal to minus 1 raised to p minus 1 by 2. We have proved the result up to this portion of the first part, and the second part, now to prove the second part, we have to consider the cases, different cases depending upon the value of p. We have to consider the value of minus 1 raised to p minus 1 by 2 depending upon the value of p. And we know that minus 1 raised to p minus 1 by 2 equal to 1 only if p minus 1 by 2 is even, and that is p minus 1 by 2 equal to 2k. You can take that quantity, since this quantity equal to even, since we take this quantity equal to as an even number. So where k can be any k can be some integer number, some integer. So you can write then p minus 1 equal to 4 times by cross multiplication we get that 4k, and thus p is equal to 4k plus 1. Okay, therefore in this case we get that thus we can say that p is congruent to 1 mod 4, thus in this case. Okay, therefore we get the 1, we get the value 1 from this quantity minus 1 raised to p minus 1 by 2. We get 1 when do we get we get that value when p is congruent to 1 mod 4. Next we assume that minus 1 raised to p minus 1 by 2 equal to minus 1. In that case you have to consider when it is equal to minus 1, but this quantity we get that value equal to minus 1 if only if p minus 1 by 2 is an odd number. That's p minus 1 divided by 2 equal to 2k plus 1 you can take, where k is some suitable integer. Therefore p minus 1 equal to 4k plus 3. 4k plus 3, therefore p is congruent. Then we have p is congruent to 3. We can show that p is congruent to 3 mod 4, and thus concluding that all the previous steps, we can finally we can write that minus 1 bar p, the Legendre symbol minus 1 bar p equal to minus 1 raised to p minus 1 by 2 equals 1 if p is congruent to 1 mod 4 and equal to minus 1 if p is congruent to 3 mod 4. Next theorem, in the next theorem we are going to find the value, the Legendre symbol value 2 bar p. See, in n bar p, if you are taking n equal to 2, we get 2 bar p, and that value we are going to show that 2 bar p equal to minus 1 raised to p square minus 1 divided by 8, p square minus 1 by 8, and equal to that, again that quantity equal to, we get two different cases for that value. One, if p is congruent to plus or minus 1 mod 8, if p is congruent to plus or minus 1 mod 8, and equal to minus 1 if p is congruent to plus or minus 3 mod 8. So let us consider, now to prove this, let us consider the following congruence expressions. So we begin with a set of congruence expressions. First is p minus 1 is congruent to 1 into minus 1 raised to 1. See, minus 1 raised to 1 we write p minus 1 is congruent to 1 into minus 1 raised to 1 mod p. That you can verify, you can check that by simplifying this expression. You can verify. Next expression is 2. Next equation is 2 is congruent to 2 into minus 1 square mod p. Okay, next is p minus 3 is congruent to 3 into minus 1 cube mod p. Next 4 is congruent to 4 into minus 1 raised to 4 mod p, and you can extend this writing this way. You can write a set of equations and ending with the equation r is congruent to minus 1 by 2 into minus 1 raised to p minus 1 by 2 in mod p. So this is the way, this is the general form of the equation that we have written here. The general form of the equation. You can using this or looking at this expression, you can looking at this congruence equation, you can write all the equations which are appearing above. Okay, then what we are going to do, we have to, then r is the least, see here r is the last expression in the r in this last expression. This is the last expression. This number r in the last expression is either, this is r is now used in to represent some number. That number is actually it is either p minus 1 by 2 or it is p minus 1 by 2. So two possibilities are there for there exists for the value r can be either p minus 1 divided by 2, or it can be p minus 1 by 2. Next we multiply all these congruences and all these congruence equations and get a new congruence and get a multiplied new lengthy big congruence equation we get by multiplying all these numbers. Left expressions, left numbers are all the numbers which are available and on the left side are multiplied, and then that quantity will be congruent to the product of the right hand side of the congruence will be then is congruent to that expression product, and then mod p you can write. And this is the expression that you are going to get. 2 into 3 into 4 into 6 into etc. to p minus 1 is congruent to 1 into 2 into 3 into 1 to 2 into 3 into etc. to p minus 1 divided by 2 into minus 1 raised to because there are in all these equations we have minus a power of a suitable power of minus 1 raised to 1, minus 1 square, minus 1 cube, etc. All these are there. So you have to combining that minus different various powers of minus 1, we get minus 1 raised to 1 plus 2 plus etc. plus p minus 1 by 2, and then it you can write mod p. Here you can then rewrite the left hand side as 2 into 1, then 2 into 2, 2 into 3, etc. And then here this quantity can be 2 into p minus 1 by 2, 2 into p minus 1 by 2. This is for convenience. For convenience, conveniently you can cancel this quantity from both sides. So for this purpose, here it is written. It is written in the factorized form, and that quantity is then congruent to. You can combine this. You can and you can see that it is this quantity is equal to p minus 1 divided by 2 or factorial into minus 1 raised to this quantity is when you add this quantity you have that simplified algebraic expression that is p square minus 1 divided by 8, which is equivalent to the power that you can see here in the bracket, power of minus 1. Okay, and that is p square minus 1 divided by 8. Then you get modulus of 8, and next okay, here therefore we get 2 raised to 2 to the power of p minus 1 by 2 into p minus 1 by 2 factorial is congruent to p minus 1 by 2 factorial into minus 1 raised to p square minus 1 divided by 8 mod p. And now you can cancel from both sides p minus 1 by 2 factorial. P minus 1 divided by 2 factorial can be cancelled from both sides. It's because you can the cancellation is possible and subject to some condition that this product must not be divisible by the quantity that you are going to cancel from both sides must not be divisible by p, and that condition is satisfied here because p is a prime number, and because p is a prime number, and you can see that all the numbers that is appearing in this factorial are and the number is less than that prime number p. The product, this is the product of the numbers from 1, 2, 3 etc. up to p minus 1. So and those numbers these numbers do not contain p as a factor. So you can see that you can say that, and these factorials are the factorial, and that what is the factorial? The factorial p minus 1 by 2. The factorial is not divisible by p, and so you can cancel both sides from both sides this quantity without any without making any problem. You can cancel, and we get that the simplified expression 2 raised to p minus 1 divided by 2 is congruent to minus 1 raised to p minus 1 divided by 8 mod p. Here also we have, and this is not the final stage, a final step of that proof. Here you have a simplified congruence equation, and this congruence equation has the quantity 2 raised to p minus 1 2 raised to p minus 1 by 2, and that connects by using congruence relation connects to minus 1 raised to p square minus 1 divided by 8 with respect to mod p with respect to the modulus of p. Okay, and we again now using the next we take a new step using Euler's criterion. We use the Euler's criterion to find the Legendre symbol. The Legendre symbol 2 bar p is equal to 2 raised to p minus 1 divided by 2 mod p. Okay, and also since we have 2 to the power of the Legendre symbol 2 bar p is congruent to minus 1 raised to p square minus 1 by 8 mod p. So this is copied from the above step, from this step. Okay, and therefore since these two quantities are same, you can combine them, and you can see that 2 raised to 2 to the power of p minus 1 by 2 is congruent to minus 1 to the power of p square minus 1 divided by 8 mod p. Okay, you can combine these two. The right hand side of this congruence equation can be combined, keeping that modulus of p along with it. Okay, next we want to show that by considering all possible values of the Legendre symbols, all possible values of this quantities 2 raised to the power of p minus 1 divided by 2 and minus 1 raised to all possible values will be considered to show that to prove the equality. To prove the equality of this quantity. Okay, next we want to establish the equality of the two quantities. The two quantities 2 bar p, but the value as this is the Legendre symbol, 2 bar p is a Legendre symbol. We know that it has value either plus 1 or minus 1, and also minus 1 raised to p square minus 1 divided by 2 has value either plus 1 or minus 1. Therefore, you can consider, when we consider the quantity 2 bar p, the Legendre symbol 2 bar p minus 1 raised to p square minus 1 by 2 by 8 can have the values 0, plus 2 or minus 2. We have you can refer the previous examples or previous cases that we have discussed in detail, in which we discussed in detail that various values of assigning various values to these quantities, and how we have established the equivalence or the equality of the two quantities when they were connected initially, when they were connected using the congruence symbol, and that how did we replace that congruence symbol by using the equality symbol. So you can refer that computation, but since the steps are very similar to that previously discussed steps, so we will avoid that. Here we are going to get the value 0, plus 2 and minus 2. Okay, then since p is we have that fact that p is an odd prime, therefore it cannot divide that quantity plus 2 or minus 2, so we have to avoid that. Hence we get that the quantity equal to 0. Thus finally we get that 2 bar p is equal to, thus we get that 2 bar p is equal to minus 1 raised to p square minus 1 divided by 8. Okay. Next we will establish the values of the two different values for. We will show that minus 1 raised to p square minus 1 divided by 8 can have two different values depending upon the value of p. In the first case, we have minus 1. Minus 1 raised to p square minus 1 by 8 is when we consider this quantity, we can see that it is either plus 1 or minus 1. Okay, and when p square minus 1 by 8 is even, suppose p square minus 1 divided by 8 is even, then p square minus 1 divided by 8 can be written equal to 2k, where k is some suitable integer, some suitable number. So number means integer, 2 into k, and then p square minus 1 divided by 8 equal to 2k. Therefore p square minus 1 equal to 16k, and hence p is equal to, then suppose we take p is equal to 8k plus or minus 1. Let's take p is equal to 8k plus or minus 1. All primes, can we take all prime equal to 8k plus or minus 1? Yeah, this is possible. So we take p is equal to 8k plus or minus 1, then we get that, thus we get that by substituting this one. Yeah. If suppose we take, or we can take p is equal to, so we suppose that p is equal to 2k plus or minus 1, then immediately you can write p is congruent to, in this case p is congruent to 1 mod 8, and then when we substitute this quantity, in this case on this specially taken p can be substituted there, p square minus 1 divided by 8, and then expanding and that square, and then after cancelling that we get that p is equal to plus or minus 1 mod 8. Therefore p is equal to okay, and then we get that this quantity is equal to 1. That is when p is going to plus or minus 1 mod 8. When p is congruent to plus or minus 1 mod 8, we get that the quantity p square minus 1 divided by 8 is even, and when that quantity is substituted there as the power of minus 1, we get that plus 1 there, plus 1. Okay, and next case we assume that minus 1 raised to, so in this case, in the first case we assume that the quantity is positive, plus 1, minus 1 raised to p square minus 1 divided by t is plus 1 we have assumed. Next we assume that minus 1 raised to p square minus 1 divided by 8 is minus 1. With this assumption then you can take p square. When this is minus 1, this can be minus 1 only if this quantity is odd, that is p square minus 1 divided by 8 is odd. So you can take p is equal to, in this case you can take p is equal to 8 into t plus or minus 3, 8t plus or minus 3, where t is some integer, and therefore p now we can write p is going to plus or minus 3 mod 8. P is going to plus or minus 3 mod 8. Okay, corresponding to this choice of p, you can find p square minus 1 divided by 8 equal to when p square is substituted and expanded, we get this quantity, and then minus 1 can be added to that, or 1 is subtracted. After that, this quantity is divided by 8, and that quantity, and therefore since this quantity is odd, therefore we get that, and thus in this case we get that. Okay, definitely this quantity is odd, we can verify that, and since after simplifying p square minus 1 by 8, we get that this quantity will be an odd quantity, and since this quantity is odd, that odd quantity then ensures that the power minus 1 to the power of p square minus 1 by 8 is minus 1, and this happens when p is equal to plus or minus 3 mod 8. And therefore we can conclude that 2 bar p is equal to minus 1 to the power of p square minus 1 divided by 8, and that quantity equal to 1 if p is going to plus or minus 1 mod 8, and equal to minus 1 if p is going to plus or minus 3 mod 8. Okay, thank you.